Hi guys, welcome to our second video of this computer lab exercise. We're going to fit the linear model, regression model into and using the function LM. So before we start, you might want to have a quick look on the our documentations. But in case you don't want, I will just walk through with you very quickly. As you can see that the first argument we're going to provide for the LM function is the formula, and which is here. As you might already expect that the left hand side of the tutor is the dependent variable, the name of the dependent variable, and the right hand side of the tutor is the regressors. Like this is a simple regression model, so we only have one regressor, and if you have multivariable, if you want to include more explanatory variable later on, you will use the plus sign and then and so on and so on. Yeah. So, and the second argument you're going to need is the data, and then you need to specify the data frame. And then you would extract the column from this data frame, yeah, to run the regressions, and then we save the output as the regress underscore CAPM. As you might see, it has a LM class, and if we simply enter the name of the objects, is going to give us a function call and the coefficient estimate only, which is not sufficient in most cases, right? So we can use summary. It would be good to use the summary functions on this LM object, as first of all, you give a detailed textual summary of the regression result, not only the function call, not only the coefficient estimate, but also like the distribution of the residuals, also the standard error of the coefficient estimate, the t-value, p-value. Oh, please note that like the t-statistic provided here is based on the assumptions that the hypothesized value for the null hypothesis is 0. And then, so if you have an arbitrary hypothesized value, then you need to calculate the t-value by your own. And also the p-value provided here is based on the two-tail test, and also using the t-distributions. So if you are performing a right or left tail test, or you're using the standard normal distribution on the large sample, then you need to calculate the p-value on your own. So, and also like you can see that like you provide the R-square and the adjusted R-square, and also the degree of freedoms. So it is much more informative. And second of all, the reason why you might use summary on this LM object is that it's more easy to extract information from the regression result. Like, of course, you can calculate the t-statistic like by copy and paste from the table printed. But that's one problem. First of all, these values are rounded, and second of all, like you might end up like copy one more or less digits. Like it's more easy to generate errors. So so it's better to extract the information directly from the object created. So in order to do so, we might store the output of summary functions this LM object into and create a new object name, and then if we simply call it the name is exactly the same we saw when we run the summary regression CAPM, but in fact it is a list. Like if you try type of is a list, right? And this list has 11 elements, and we can extract the elements using the $sign operators For instance, if we would like to extract the degree of freedoms, yeah, we can see that like it is 196 degrees. And suppose we would like to know more about the coefficient estimate. We extract it, and it is a matrix. Like so, as this element, a coefficient element, is stored as a matrix, then we can extract the info as a matrix. Like for instance, like if we would like to have the t-value of the intercept. So it's the first row and the third column, right? So before comma is the row, and the after comma is before comma is row, and the after comma is the column. So you can see that like we can directly extract the information from the regression result for the hypothesis testing.